So my name is Rob Nertney. I am a principal software architect at NVIDIA. I'm joined today by Spencer Gilson, and today what we're going to be doing is, hoping it's up, good, talking about confidential computing and some of the future solutions that are coming with Vera Rubin. You're going to see I've got 25 minutes to go through pretty deep topics, so we have a lot of other talks that you can go see, presentations from GTC, but hopefully this teaser will give you some time to see what we've been working on, where we've come from, and where we're going in the future. Now, looking at this, we'll kind of level set. So I've seen and met a few people here today who are here trying to figure out what is confidential computing. I'll see a lot of other common faces over the years where we can say, I know what it is, I want to see what's new, I want to meet people who are using it and how it's going. So we're going to level set, we're going to go through into what's happening kind of in the future here with Vera Rubin, and then other solutions for attestation that are outside the realm of confidential computing, because these things go together, the verifiability of our workloads, not just for the privacy and security of the trusted execution environment, but other use cases for fleet deployments as AI starts to proliferate through the planet. Now, today what we've got is a story of confidential computing. We started with Hopper in 2024. This was a single GPU that you could plug in either PCI Express or the SXM HGX boxes. And the idea here was we were the first to bring that trusted execution environment to a PCI accelerator device. And what this allowed you to do was offload the prompts, the weights, the models, and in a testable, verifiable environment. We partnered with Azure, we partnered with Google, we've partnered with a lot of customers in the clouds who were able to bring this in and allow people to start to use this and figure out what it was all about. Then we had the AI explosion of agentic AI, the early days saying, I need more compute in this box, but I also want that confidential computing. Now, we didn't have NVLink encryption enabled on the Hopper devices. So what we did was we used attestation to allow users to choose their own adventure when it came to threat models. And we came out with what we called protected PCIe, because we wanted to take a very conservative approach, as many of us here do, when it comes to confidential computing, and try and make that your data doesn't leave your environment in plain text. So when you start hearing in the Hopper generation, you'll see confidential computing, that's PCI Express, fully protected, and protected PCIe, which has the same PCIe protections, just plain text NVLink. They attest differently, so you know what mode you're in. On day one, we had a high availability attestation services. This had our RIM service with measurement files. It had an OCSP to check for the revocation status of these measurements for firmware, for drivers. And then with that, if you just wanted a one-click, one-stop verification service, send your evidence up. We do the verification, back comes a token telling you you have attestation. Blackwell came, generation 2. Everything gets better with the next generation. We moved and encrypted those NVLinks. This enables you to have different topologies inside your fleet. 1 GPU, 2 GPUs, 4 GPUs. Still within the HGX box. With this, you also say, well, with Blackwell, what else could we add? The RTX Pro series, bringing the enterprise to having more flexibility if you don't need a whole box of B200, B300. RTX Pro 6000, you can have the smaller models, your edge deployments, have that solution ready for use. Now for attestation, we had two flavors kind of historically in the past. One is the use case attestation. This is confidential computing. You are a tenant sitting in your TEE. You need to go to the GPUs, the NVSwitches, anything that basically was NVIDIA owned, and said, tell me what your evidence is, your state is. I want it chained to a device identity that can go to NVIDIA authenticity, and then I want to chain the measurement files to a measurement identity rooted at NVIDIA, and then I want to make these together, do the comparison, the verification, and continue. Now with this, we use TCG-style RIMs. This was sufficient for our needs. This was the best use case of how we were able to get that out. We also had something called infrastructure attestation. Now this is kind of the little known attestation that's been around for actually much longer. What this allowed a third-party infrastructure to do was to challenge the rest of the chips on a system that we provide. This includes the HMC. This includes, you see the FPGA here, the GPU, the NICs. Basically, if this was a NVIDIA provided firmware, you as an infrastructure out of band could take this, challenge it against a co-RIM, and validate that, yes, nothing happened in my supply chain. Now, this, all we did at the point was we said, another team over here wrote a co-RIM and provided this with the access APIs to go challenge these devices and get those measurements. What you're going to see in today's talk is we're going to bring this together and show how in the future we're bringing these two disparate things into the larger story as well with the NVIDIA Attestation solutions. One slide that basically has many hours of talking behind it is, of course, we announced this year at GTC, the scale up, the next step in that journey. 1 GPU with Hopper, 8 GPUs with Blackwell. NVL72 Vera Rubin is going to bring the whole rack scale with confidential computing across all of those GPUs into the CPU realm and give you that full end-to-end protection now at a rack scale. So what we want to go through here is some of the story going into, well, now we need to bring in the ARM processor. What is CCA? What do they talk? Do they talk co-RIM? Do they talk profiles? How do we integrate this with the last group that was up here with standards bodies, the standardization of profiles and talking within an IETF co-RIM standard so anyone can verify this. Anyone can take that evidence and put it together with their own solution to make sure that what you're running on is what you expect it to. Now, when we scale up to 72, we're no longer in a box. When you're in a box where it's just 8 GPUs, you can look down and say, okay, I can bind this to a CPU. I can go and take all 8 of these and independently attest them and bring this into a single node where I'm sitting in a TE. But when you go to multiple nodes in a rack, you have to ask yourself, how do I now attest my neighbor? How do I make sure that this node is something I trust? How do I make sure that all the constituent parts of that are also attested? So what we have to come up with here is the ability to have some sort of software stack sitting on all these nodes. And who's going to be the leader? How do I challenge them? How do I make sure I can get encrypted paths to them? Because now I have to do relay attacks. I have to do replay attacks. I have to worry about these things when talking outside, even within a rack connected by an NVLink array. So what we've been doing here is some of the considerations. I get a lot of questions of like, what's next? What are we going to do? When are we going to scale up? And the idea is that we have got line of sight to what we want to do here. And the roadmap is bringing it right here where we can say, with these considerations, you're going to start to see the software stack helping the verification part of this scale-up solution. You're going to have the stack basically discover the nodes. It goes through and says, okay, are these mine? Do they belong to me? Have they been assigned to me? Now I have to get trustworthiness between them. Everyone needs to authenticate to each other. I need to make sure that, okay, I know you, these are mine. And then we set up a policy, because one thing NVIDIA prides itself on is the choose your own adventure as to what happens when anything in your system you can figure out via a series of claims, verification results, what you want to do with things. Obviously, we have to secure all the data paths. And then throughout this process, a big thing that we always want to worry about here is saying, do I periodically attest? Do I want to enable that? I need to periodically make sure that if there's any sort of error handling, right? How do I get reliability information out of this? All this is being taken into consideration when we start working into the scale-up solutions. So what you'll start to look forward to on this as we kind of go into our next area with my partner over here, Spencer, is trying to see what it takes to scale these solutions. A little bit more deep going into what the industry is looking at and kind of the things that we like to go through to try and make sure that the CPU, GPU, and that whole story is cohesive. So with that, I'll pass over to Spencer.
Thanks, Rob. So what I'm going to be discussing is a different type of scaling, and it's going to be the standards we're going to use in order to scale attestation in terms of maintainability across all of our different devices and new modes that we're going to be supporting. So previously, we've kind of relied on SPDM for Hopper and Blackwell and NVSwitch attestation, but we have been lacking a direct mapping to the RIM. So in many cases, this requires a lot of handwritten verifier work in order to properly do attestation. So we understand that a lot of our partners have their own reasons to maintain their individual verifiers. So we're looking at how do we make the mapping of evidence to CORIM to attestation results even more smooth. So looking at the solutions out there, CoEv is going to be a pretty big addition to Vera Rubin. We're going to embed it both in our SPDM transcripts for Rubin confidential computing, and we're going to also embed it in our ARM evidence. So you might be familiar with ARM's platform and realm tokens. We're going to take that a step further with concise evidence as well, so that you have a pretty direct mapping from, like I said, the evidence to the CORIM. Dice TCB info is going to be there, of course, to attest and verify all of the layers above the firmware that you're running. And that has a pretty natural mapping to CORIM as well. Just based on what's available right now, we're building on top of CORIM Draft 10. We're hoping for no more binary or wire format changes, but we'll see. In terms of attestation results, we're kind of convening around EAR, and we're looking at A4SI in addition to that. Now, briefly going into the differences between Hopper and Blackwell versus Vera Rubin. Like I said previously, we had a pretty hefty handwritten verification flow. We're hoping a lot of this will be made much more standards-based and generic with the transition to CORIM plus CoEv. And with this, we hope to onboard CPUs, NICs, DPUs much faster in all of their different modes. You also get a lot more variety in what you can express in terms of evidence. With TCG RIMs, you really only get digests, which partially leads to this reliance on handwritten verifier logic. With CORIM, you also get a pretty cool capability to express what should and shouldn't be in the TCB across different modes. So different microcodes and different firmwares might need to be measured in CC versus other modes, and you can actually switch between them programmatically without needing to bake that into the verifier. We're also looking at using RIM locators to identify the relevant reference measurements. This is more of a minor point, but this has been yet another point of handwritten logic for Hopper and Blackwell that we're looking to eliminate with this generation. Now, going a bit more broad to the other use cases that we're enabling with kind of this standardization effort. A big one is fleet scale attestation with fleet intelligence. Fleet intelligence isn't strictly an attestation solution. It's really a fleet visibility solution. You can get a bunch of great data on your power consumption, performance statistics, CVE reporting, the firmwares you're running. So you as a fleet operator get great visibility into all of your NVIDIA hardware. A pretty big component to this though is hardware attestation, where through NRAS you can get a guarantee that you're working with NVIDIA authentic hardware. And this is generally available at no cost for any GPU data center customers. Now, speaking more broadly about the future of attestation at NVIDIA, first we're looking to expand the surface of what we can verify, like I said, both in terms of modes and different devices as we onboard them. This has pretty big implications for DSX, which I haven't talked about, but we'll have an attestation component as well as fleet intelligence. Both of these can greatly benefit from attestation, and we're going to use it. Next, we're going to look at standardizing the whole stack of evidence, co-RIMs, and attestation results across all of our devices. This will take a few generations, but that's the rough direction we're heading. You'll be able to use our verifier, but the hope is that based on these standards, you can more easily maintain your own verifiers should you need to. And finally, we're looking at other opportunities to manage attestation across your entire fleet. Fleet intelligence being the first, but looking to strengthen our SLAs on our services side and adding different capabilities there. Yeah, thank you all. I'll hand it back to Rob for a final word.
All right, thanks, Spencer.
Yeah.
So I think what we end up wanting to show here is how we started this story where when attestation was just simply a supply chain look, right? A series of hashes and digests, something that we basically said, here's what you should expect. We're going to post this on a website. When you download your firmware bundle, you can start looking at the comparison here. To an industry nascent technology, confidential computing, where we started with maybe this size of room for confidential computing summits, and now we're at big places, people from all over the world flying into town, and then bringing in the realization that the industry needs to standardize. We need to come together and realize that everybody needs to verify because they're all going to provide evidence in a different way. Am I going to be a DPU? Am I a CPU? Am I x86 versus ARM? And the story comes together with the standards bodies and us at NVIDIA trying to make sure that we're at that tip of the spear, balancing the new technology with making it scalable for the future with anyone who wants to come in and bring confidential computing to their piece of hardware. So with that, we have lots more that we can end up talking about. So please feel free to reach out to some of our other talks. But I want to end with the fact that, NVIDIA's confidential computing. On here, we're hearing a lot of, I guess, a transition from what could be done, or I have hopes and aspirations for confidential computing, to these are people using it. These are people deploying it. They are counting on these attestation services. They are counting on the infrastructure attestation. They are counting on the scalability of standardization so they can write their own verifiers. We have partners such as Opaque. We've got partners such as we've set up here. We had Google, Gemini, Apple, Anthropic, all coming to deploy this because they're trusting this technology. You're going to be able to have model providers send their models to systems on-prem. You've got users with on-prem data now able to send them to the cloud. So with that, I'm really excited to be here with you guys to see that this is that turning point where people are using it. There's a big roadmap ahead of us, and we're really excited to be a part of it with you guys. So thank you so much.